Secrets to passing the FAA Part 107 drone test. If you're planning to take the FAA exam or the Recurrent test, it might be good to know and prepare for the kinds of questions that are most likely to trip you up. When questions are answered incorrectly, the FAA puts special codes on the test results forms to let students know what they need to brush up on. The PTS, or Practical Test Standards codes, will eventually be replaced by a new set of Airman Certification Standards, or ACS codes, which are more specific. The ACS system assigns a unique code to each knowledge, risk management, and skill test element. ACS will provide a better means to directly correlate with study and testing. As soon as the technical capability comes online, the ACS codes will supersede the current system of PLT codes, but the basic information remains the same. It's the codes that will change and not the test questions or answers. So, here's a look at some of the questions that have caused problems for those taking the FAA exam. These are the PLT codes for some of the most common incorrect answers. PLT 040, Interpreting Airspace Classes from Charts and Diagrams. That comes under the heading of Airport Operations. The secret to identifying the classes of airspace is the legend, which is found in the beginning of the charts book provided at the examination test site. Knowing where to look turns that portion of the test into what amounts to an open book test. So when we see a complicated map like this with overlying shelf areas, we can use the legend to figure out, for example, the area with the red dot number 2 is inside a dashed blue line, which means Addison, near the town of Hebron, is in Class D airspace, and the space above it, it's Class B airspace at 11,000 feet. So what's up? During the cold season, it's not unusual to see the abbreviation UP appear in an automated surface observation, or METAR. So what the heck is UP, and where does it come from? UP is an abbreviation for Unknown Precipitation Type. Unknown precipitation is usually only found in automated surface reports such as the one shown here. The Automated Surface Observing System, or ASOS, employs a precipitation identification sensor, also known as a light-emitting diode weather identifier. This sensor tries to differentiate between rain and snow and determine the intensity of the precipitation. In most cases, it does quite well. However, there are some times when the sensor can be fooled, and we get UP, as in I give up. So what about that automated system? PLT 059 is next on our list. Interpret information on a METAR SPECI report. Reading a METAR just takes some practice, and you can find plenty to practice on at CFI Darren Smith's website at cfidarren.com/wx-metar.htm. Give it a try, and then check your answers. The codes are listed in the Pilot's Handbook of Aeronautical Knowledge. You'll find it in Section 13. The FAA exam stresses the ability to read sectional charts, so here's an example. A radio tower is the tallest tower 4 nautical miles southwest of the indicated Class D airport. If you fly at the maximum permissible altitude above the tower, what class of airspace are you in? You'll need to be able to find the tower cluster, determine the height of the tallest tower, then add 400 feet of clearance. You'll then find that you're in a partial carve-out under the Class B's lower layer, but that going 400 feet above the top of the tower will definitely put you in the next higher level of the cake, and so now you're in Class B airspace. Another question might say you're using a drone to survey the railroad tracks that run from this city to that township. To answer correctly, you'll need to recognize that the railroad tracks run through a Class D airspace and will require FAA approval. There could be questions about crew resource management for a company that provides UAS services and how to develop a CRM policy. What is CRM? Crew Resource Management. PLT 064, Interpreting Information on a Sectional Chart. The kind of question here might be something like finding the elevation of the top of an obstruction 3 miles northwest of McCampbell Airport in Area 1 of Figure 45 in the charts book. The answers will include MSL and AGL. What have we learned about obstructions? We add the ground elevation to the height of the obstruction. The elevation is the bold number expressed in feet above sea level. The height is above ground level, or AGL, but if the question asked for the elevation, the answer would be in feet MSL. Be sure to review the chart section of the Pilot's Handbook, Chapter 15. What is a PIREP? It's a pilot's report of current conditions. The abbreviations are just like the ones in METARs. Take some time to review Section 13-8 in your Pilot's Handbook of Aeronautical Knowledge. It's like riding a bicycle. It just takes practice. The code for missing PIREP questions will be PLT 061, Interpreting Information on a PIREP. The study material is found in the Pilot's Handbook in Chapter 13. Next on our list is PLT 161, Recalling Airspace Classes, Limits, Requirements, Restrictions, Airspeeds, and Equipment. The resource for this information is Part 91 in the FAA manual, specifically 91.117, Speed, 91.119, Minimum Safe Altitudes, 91.123, ATC Clearances, 91-127, 129, 131, and 135, Operations in Specific Airspace, 91.155, Basic Weather Minimums, and so on. Now, you don't need to memorize, so don't even try. Reading this section a few times should make you familiar enough with the material to recognize the correct answer among the choices in a test question. If you miss a question about collision avoidance and scanning techniques, you'll see code PLT 194 in your text report. Review section 4-3-23 in your copy of the AIM, along with Advisory Circular AC 90-48, and become familiar with the basics. For example, scanning for traffic using off-center viewing and systematically focusing on sections of the sky rather than sweeping across the field of view. That's good practice for the visual observer. But some of the points under this section don't seem to relate to unmanned aircraft, but you'll still need to know. For example, turning on landing lights below 10,000 feet or within 10 miles of an airport and maintaining the proper altitude in the traffic pattern. You might say the same about this one, PLT 323, Recall NOTAMs, Classes, Information, and Distribution. The reference is Section 5-1 in the FAA. That's from the section on airport operations. Review that section and you'll be ready for the test. PLT 328, Recall Performance Planning, Aircraft Loading. This relates to the study section on aircraft loading in the Pilot's Handbook in Chapter 9. Most of the problems with questions in this category have to do with just being careful about reading the diagrams. It's a good idea to have a straight edge when you take the test, but if you don't, just fold the scratch paper that is provided. Again, practice is the only way to go. Also remember that the useful load is what you have left after you account for special equipment. Allowable useful load is decreased when the extra equipment is added. Seems logical. PLT 345, Recall Pressure Altitude. This is a subject that can be confusing. Just remember that when you go higher, the air is less dense. So, a higher pressure altitude is where the air pressure is actually lower, because there's less air stacked above. The opposite is true at low altitudes, where the air is more dense at low pressure altitudes. Got that? Also remember that density altitude is a function of temperature and barometer. There's an old pilot saying, high to low, look out below. That means that when going from a high-pressure area to a lower-pressure area, if the altimeter is not corrected or adjusted to the correct barometric pressure, the plane is actually lower than what the unadjusted altimeter displays. That means a possibility of unexpectedly colliding with terrain. The chart that will likely appear on the test is Figure 8 in the Charts book. Look over the Charts book and the Pilot's Handbook in Chapters 4 and 11. PLT 399, Display Inspection of Licenses and Certificates. The resource is FAR 91, Section 203. What needs to be carried aboard an aircraft? An appropriate and current airworthiness certificate. An effective U.S. registration certificate issued to the owner. And a current and approved airplane or rotorcraft flight manual. Does this apply to small UAS? Well, sort of. You can't carry the manual aboard the aircraft, but it might be good to carry a copy to the job. Personally, I keep a copy in the pocket on the outside of the carry case. Also take some time to read through Part 107 in a current version of the FAR AIM, or look it up online. It's only 8 pages. There could be questions about NOTAMs on your exam, which are classified under the code PLT 323, Recall NOTAMs, Classes, Information, and Distribution. For that, you'll want to review Section 5-1 in the FAR AIM manual. PLT 493, recall the dynamics of frost, ice, and snow formation on an aircraft. Again, the FAA put this in to see if you studied. A small UAS is not very likely to encounter icing conditions in normal operation, but it's in the test bank, so don't let it catch you by surprise. When the wind blows on you, you get colder, right? That's what the weather guy calls wind factor chilling. When moist air blows against an object like this plant, ice collects, and the same thing happens to a wing. The air can be just above freezing, but a wing moving through that air can be cooled to freezing temperature, at which time the moisture in the moving air will collect on the wing in the form of ice. That accumulated ice increases wing turbulence and decreases lift. Check the pilot's handbook 12-24 under the heading Supercooled Water Freezes on Impact with Aircraft. Hopefully this review will help you avoid some wrong answers on your exam by being prepared. My students, in my on-site classes and online, report scores of 88 and better, as high as 98, because they are prepared. You can find my online training course at 107studyguide.com. For extra study, my Remote Pilot Study Guide in print or ebook can be found online at Amazon and other book sources. And remember, understanding is the basis of knowledge, and knowledge is the foundation of safety. If you like what you see and you'd like to see more, you know what to do. Click the button below. Thank you.